Today we're talking about, we are treating another type of partial fractions. Let's call that C. And they are fractions with repeated factors. They're actually fractions whose denominators are repeated. Let's solve a few questions on that. Examples. Example. Express as partial fractions. Roman figure 1. 2x squared plus 39x plus 12 divided by 2x plus 1 squared times x minus 3. Roman figure 2. X squared plus 2x plus 18 divided by x times x squared plus 3 squared. And Roman figure 3. X minus 2 divided by x squared times x minus 1 squared. Now let's solve that. The first fraction is 2x squared plus 39x plus 12 divided by 2x plus 1 squared times x minus 3. This is a compound fraction we want to resolve into partial fractions. And we know the rules. That's equal to the factor 2x plus 1. The factor 2x plus 1 is a linear factor. But it is a repeated factor because its power is greater than 1. It has an exponent 2, which is greater than 1. That means it is repeated. So it's going to have 2 partial fractions. And that's... So we say a over 2x plus 1, because the numerator of a linear factor is a constant, but this linear factor is a repeated linear factor because it has an exponent that's greater than 1. So it's going to have 2 partial fractions. So that's a over 2x plus 1 plus b over a over 2x plus 1 plus b over 2x plus 1 squared plus the factor x minus 3 is a linear factor, so it just takes a constant as the numerator of its partial fraction, and that's c over x minus 3. Now we continue the process. The LCM of the denominators is 2x plus 1 squared times x minus 3, and that's a times 2x plus 1 times x minus 3 plus b times x minus 3 plus c times 2x plus 1 squared. Now the numerators are the same. The denominators are the same. That means the numerators are equivalent. So that means 2x squared plus 39x plus 12 is equal to a times 2x plus 1 times x minus 3 plus b times x minus 3 plus c times 2x plus 1 squared. So what do I do? Let me put in x equals 3. Putting x equals 3. 2 times 3 squared plus, is it better to put x equals 3 or to expand the right hand side? Yeah, putting x equals 3. Let me put x equals 3. 2 times 3 squared plus 39 times 3 plus 12 is equal to a times 2 times 3 plus 1 times 3 minus 3 plus b times 3 minus 3 plus c times 2 times 3 plus 1, which means 3 minus 3 is 0, and that means the whole of this is 0. 3 minus 3 is 0, that means the whole of this is 0. And we are left with the right hand side is 147. 9 times 2, 18. 90, 117 plus 12. 100 and that's going to give us, let me check that again. 3 squared is 9 times 2, 18 plus 39 times 3, which is 117 plus 12, and that's 147. So 147 is equal to, the right hand side is 2 times 3, 6 plus 1, 7. 7 times 6, 7c. And that means c is 147 over 7, which is, that is it. Pardon me, this is supposed to be squared. That's supposed to be, when we put x equals 3 in the identity, the right hand side is supposed to have c times 2 times 3 plus 1 all squared, and that's supposed to be 49c. 49c. So that means c is 147 divided by 49. 147 divided by 49, and that's 3. So c is equal to 3. Now what else can we put in the identity to get another value, to get the value of another constant? Let me put x equals minus 1 over 2. Putting x equals minus 1 over 2. That means 2 times minus 1 over 2 squared plus 39 times minus 1 over 2 plus 12 equals a times 2 times minus 1 over 2 plus 1 times minus 1 over 2 minus 3. That's correct. Plus b times minus 1 over 2 minus 3 plus c times 2 times minus 1 over 2 plus 1. 2 times minus 1 over 2 plus 1 all squared. which means, so what do we have? Minus 2 times minus 1 over 2 is minus 1. Minus 1 plus 1 is 0. This is 0. That means the whole of this is 0. 2 times minus 1 over 2 is minus 1 plus 1. That's 0. This is 0. And that also means the whole of this is 0. So on the left hand side, we are left with minus 1 over 2 squared is 1 over 4 times 2, which is 1 over 2. We're left with 1 over 2 plus 1 over 2 minus 39 over 2 plus 12 equals, that's minus 7 over 2 equals minus 7 over 2b. And that means I want to write 9 properly here. And that means 1 over 2 minus 39 over 2. 1 over 2 minus 39 over 2 minus 39 over 2 plus 12. And that's minus 7. That means minus 7 equals minus 7 over 2b. This simply means b equals 2. Let me show that minus 7 equals minus 7 over 2. Minus 7 over 2b. When you cross multiply, what do we have? We have this is minus 7 over 1. So that means 1 times minus 7b. Minus 7b equals minus 14. And divide both sides by minus 7. Minus 7 cancels minus 7. Minus 7 here 1. Minus 7 here 2. That means b is equal to 2. So that's why. So yeah, that was how I got b. Now, what else can I substitute for the value of x in the identity to get a? Okay, let me put x equals 0 in the identity. Putting x equals 0. That means 2 times 0 squared plus 39 times 0 plus 12 is equal to a times 2 times 0 plus 1 times 0 minus 3 plus b times 0 minus 3 plus c times 2 times 0 plus 1 all squared. And that means 12 equals, the only thing we'll be left with on the left hand side is 12. And on the right hand side we have minus 3a minus 3b minus 3a minus 3b plus c. And that means I know the values of c and b, so I'm substituting the values of c and b. I'm substituting the values of b and c, which means 12 equals minus 3a minus 3 times b, which is 2, plus c, which is 3. B is 2 and c is 3. So that simply means 12 equals minus 3a minus 3. Minus 3 times 2 is minus 6, plus 3 is minus 3. And that means 3a is equal to minus 3 minus 12. And 3a equals minus 15. And therefore a equals minus 5. And now that we have the values of all of the constants, then we can write the partial fractions that represent the partial fractions into which the compound fraction 2x squared plus 39x plus 12 over 2x plus 1 squared times x minus 3 has been resolved. So that means 2x squared plus 39x plus 12 equals 2x plus 1 squared times x minus 3. 2x squared plus 39x plus 12 divided by 2x squared plus 2x plus 1 squared times x minus 3 is equal to a, which is minus 5, over 2x plus 1 plus b, which is 2, over 2x plus 1 squared plus c, which is 3, over x minus 3. And those are the partial fractions into which the compound fraction has been resolved. Now we go to the second. It's just as simple as that. The concept of repeated factor is about the power that the factor has, because that is what determines the number of partial fractions that factor will give. If it has a power 2, then it's going to have 2 partial fractions. If it has a power 3, it will have 3 partial fractions. But if it has just power 1, it has only 1 partial fraction, and in that case we say it is not repeated. It becomes a repeated factor when its factor is greater than 1. Now we go to Roman figure 2. Roman figure 2 is x squared plus 2x plus 18 divided by x times x squared plus 3 squared, and that's equal to x is a linear factor, so it just has a constant as the numerator of its partial fraction, plus x squared plus 3 is a non-factorizable quadratic factor, and it has a power that's greater than 1, which means it is repeated, so it's going to have 2 partial fractions. And we know that the numerator that is assigned to a non-factorizable quadratic factor is a polynomial of degree 1, which is the most general, it's a polynomial of degree 1, which is a linear factor. So that means bx plus c over x squared plus 3 plus dx plus e over x squared plus 3 squared. This dx plus e over x squared plus 3 all squared, we're having that because the factor is a repeated factor. This second partial fraction for the factor x squared plus 3 is as a result of the repeatedness of its repeatedness. So, or simply of its repetition, it has 2 partial fractions because it is repeated. So the LCM of the denominators is still x times x squared plus 3 squared, and this means a times x squared plus 3 all squared plus b times x squared plus 3. There you go again. What a mistake. Plus bx plus c times x squared plus 3 plus, I want to move that away from me. So a times x squared plus 3 all squared plus bx plus c times x squared plus 3 plus dx plus e. I was almost going to write c plus dx plus e times x. Now the numerators are the same, the denominators are the same, and that means the numerators are also equivalent. X squared plus 2x plus 18 equals a times x squared plus 3 squared plus bx plus c times x squared plus 3 plus, I'm going to write the last one here, dx plus e times x. Now, I want us to, here now, we are going to expand the right hand side. Yeah, before I begin to expand, let me expand these factors so we can just multiply easily. X squared plus 3 squared is the same as x raised to the power 4 plus 6x squared plus 9. X squared plus 3 squared is x raised to the power 4 plus 6x squared plus 9. And x times x squared plus 3 is the same as x cubed plus 3x. So we can come here, a times x squared plus 3 squared is going to be a x raised to the power 4 plus 6a. I already know that x squared plus 3 squared is x raised to the power 4 plus 6x squared plus 9. So I'm just multiplying a by that, which means a times ax raised to the power 4 plus 6a x squared plus 9a ax raised to the power 4 plus 6ax squared plus 9a plus bx plus c times x squared plus 3 is x cubed plus 3x. Now I want to multiply this by bx plus c, which means bx raised to the power 4 plus 3bx squared plus cx raised to the power 3 plus 3cx. Let me show what I did there. Bx plus c times x cubed plus 3x is the same as bx raised to the power 4 plus 3bx squared plus cx cubed plus 3cx. And that's it. So we continue with our expansion. Plus 3cx plus dx squared plus ex plus dx squared plus ex. Let me erase our rough work. Now we continue. So we can now, okay, now let me collect like terms. Ax raised to the power 4 plus bx raised to the power 4 plus cx cubed plus 6ax squared 6ax squared plus, you really have to be careful not to omit any of the terms or multiply, or make a mistake in your expansion of the right hand side. Where did I stop? Plus 3bx squared plus dx squared plus 3cx plus ex plus 9a. Let me count the number of terms I have in the previous equation. 1, 2. On the right hand side of the previous equation. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me see if it's the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. Now, let me factor out the common terms. That's a plus b x to the power 4 plus. Now, okay, I'm factoring out the common variables. This is the same as a plus b x to the power 4 plus c x to the power 3 plus 6a plus 3b plus d x squared plus 3c plus e times x plus 9a. Now we can compare coefficients. Now comparing the coefficients of x raised to power 4. The coefficient of x raised to power 4 on the right hand side is a plus b, but there is no x raised to power 4 term on the left hand side. That means its coefficient is 0. So a plus b is equivalent to 0. That's equation 1. Comparing the coefficients of x raised to power 3. The coefficient of x raised to power 3 on the right hand side is c, but on the left hand side there's no x cubed term. That means its coefficient is 0, and that means c is equivalent to 0. So we have got c. Now comparing the coefficients of x squared. The coefficient of x squared on the right hand side is 6a plus 3b plus d. 6a plus 3b plus d. And the coefficient of x squared on the right hand side is 1. That means 6a plus 3b plus d is equivalent to 1. I want to call that equation. Let's call that equation 2. Now I'm comparing the coefficients of x. Comparing the coefficients of x. Comparing the coefficients of x. The coefficient of x on the right hand side is 3c plus e. And the coefficient of x on the left hand side is 2. That means 3c plus e is equivalent to 2. And that's equation 3. Now comparing the constant terms. The constant term on the right hand side is 9a, and the constant term on the left hand side is 18. That means 9a is equivalent to 18, and that simply means a is equal to 2. So we found the values of a and c. Now what else Oh, I can put C in 3 to get E. Let me check and be sure that I didn't omit any other X term in the identity to get the equation 3C plus E equals 2. Let's see. Okay, I think we are still in line. So putting C in putting C in 3, putting C in equation 3 times 0 plus E is equal to 2. 3 times 0 plus E is equal to 2. And that means 0 plus E equals 2, which means E equals 2. What else? A plus B equals 0. Putting A, since I already know the value of A, putting A in 1. Putting A in equation 1. 2 plus B is equal to 0, and that means B is equal to minus 2. What am I left with? I'm left with D. Okay, putting A and B in equation 1, putting A and B in equation 2, putting A and B in equation 2. That's to get the value of D. 6A plus 3B plus D equals 1. 6A is equal to 2. That means 6 times 2 plus 3B. That's 3 times minus 2 plus D equals 1. 6A plus 3B plus D equals 1. That's correct. And that means 6 times 2 is 12. 12 minus 6 plus D equals 1. That means 6 plus D equals 1. And D equals 1 minus 6, which is equal to minus 5. Which is equal to minus 5. And that means, let's see, do I have all the unknowns now? All the constants now? A is 2, B is minus 2, D is minus 5, E is 2, and C is 0. Beautiful. I have all the constants. Therefore, x squared plus 2x plus 18 divided by x times x squared plus 3 all squared is equal to A, which is 2, that's 2 over x plus B, which is minus 2. It's actually bx plus c, so I'm going to write it as minus 2x plus c, which is 0, over x squared plus 3 plus dx plus e. D is minus 5, so that's minus 5x plus e. E is equal to 2, minus 5x plus 2 over x squared plus 3 squared. Now I'm just going to rewrite this and to make it, to make it finer. So that's 2 over x minus 2x plus 0 is minus 2, so that's the same as minus 2x over x squared plus 3 over x squared plus 3 plus, I can write minus 5x plus 2 as 2 minus 5x over 2 minus 5x over x squared plus 3 squared. And that's it. So we have resolved the compound fraction into partial fractions. That's how simple it can be if you are careful enough not to avoid mistakes in your expansion and comparison of coefficients, and eventually solution of the equations that are obtained thereafter. Now we go to Roman figure 3, which is the last one. I think this should be a piece of cake too. X minus 2 over x squared. I think here we have 2 repeated factors. X squared times x minus 1 squared. That will be equal to, x is a linear factor, but its power is greater than 1. That means it is repeated. So it has 2 partial fractions. A over x plus b over x squared plus x minus 1 is a linear factor too, but because of its power 2, it's a repeated factor. That means it's going to have 2 partial fractions. That's c over x minus 1 plus d over x minus 1 squared. Beautiful. So we go, the LCM of the denominators is the same. It's still x squared minus x minus 1 squared. And this means ax times x minus 1 squared plus b times x minus 1 squared plus c times x, which is cx, c times x squared times x minus 1. That space is not taking it. I'm cutting it out. Okay. So ax times x minus 1 squared plus b times x minus 1 squared plus cx squared times x minus 1 plus dx squared. Denominators are the same, and that means numerators are also equivalent. X minus 2 is equivalent to ax times x minus 1 squared plus b times x minus 1 squared plus c times x, c times x squared times x minus 1 plus dx squared. So, is there any value I can put for x to solve for any of your knowns? Putting x equals 1. 1 minus 2 is equal to a times 1 times 1 minus 1, 1 minus 1 squared plus b times 1 minus 1 squared plus c times 1 squared times 1 minus 1 plus d times 1 squared. What do we have? 1 minus 1 is 0, and that means the whole of this is 0. 1 minus 1 is 0, and that means the whole of this is also 0. 1 minus 1 is 0, that means the whole of this is 0 too. So, what are we left with? On the left hand side, we have minus 1. 1 minus 2 is minus 1. And on the right hand side, we are left with d times 1 squared, which is d. So, d equals minus 1. Now, what else can we put for the value of x to get another constant? Putting x equals 0. Putting x equals 0. Putting x equals 0. 0 minus 2 is equal to a times 0 times 0 minus 1 squared plus b times 0 minus 1 squared plus c times 0 squared times 0 minus 1 plus d times 0 squared. And what does that give us? Let's see. 0 times a times 0 is 0. That means the whole of this is 0. C times 0 is 0. That means the whole of this is 0. And the whole of this is also 0. So we are left with minus 2 on the left hand side equals b. 0 minus 1 is minus 1. Minus 1 squared is 1 times b, which means b equals minus 2. What else can we put for substitute for x to get another constant? Putting x equals, we put 1, we put 0. Now let's put minus 1. Putting x equals minus 1. Now the value we are substituting might not give us, it might not lead to a constant directly, but we'll obtain an equation into which we can substitute the constant we have already obtained to get another one. And let's see how that works. Putting x equals minus 1. Minus 1 minus 2. It will just reduce the identity to a simpler to a simpler equation. Minus 1 minus 2 equals a times minus 1 times minus 1 minus 1 squared plus b times minus 1 minus 1 squared plus c times minus 1 squared times minus 1 minus 1 plus d times minus 1 squared. And this simply means minus 3 equals minus 2 squared is 4 times minus 1, that's minus 4a. Minus 2 squared is 4 times b plus 4b. Minus 1 minus 1 is minus 2 times 1, that's minus 2c. And this will be plus d. Minus 1 squared is 1 times d is d. Quick check. Minus a, no? Minus 4a plus 4b. Beautiful. Minus 2c plus d. That's good. And what do we have? We already know the values of b and d. So we are putting b and d here. That means minus 4a plus 4 times minus 2, which is what b is, minus 2c plus, what is d? Minus 1. So, which means minus 4a minus 8 minus 2c minus 1. And that means 4a, I'm taking minus 4a and minus 2c to the left hand side. 4a plus 2c equals, and I'm taking minus 3 to the right hand side. I'm bringing minus 3 to the right hand side. That's minus 8 minus 1 plus 3. That means 4a plus 2c equals minus 9 plus 3. That's minus 6. Equals minus 6. Let me just leave it that way as equation 1. Equation 1. Now, putting putting x equals, I just put minus 1. Let me put 2 now. Putting x equals 2. Putting x equals 2. 2 minus 2 equals 2 minus 2 equals 8 times 2. 8 times 2 times 2 minus 1 squared plus b times 2 minus 1 squared plus c times 2 squared times 2 minus 1 plus d times 2 squared. Is that correct? A times 2 times 2 minus 1 squared plus b times 2 minus 1 squared plus c times 2 squared times 2 minus 1. Yes, plus d times 2 squared. And that means 0 equals 2 minus 1 is 1. That's 2a plus b. 2 minus 1 is 1 times 2 squared is 4. That's 4c plus 4d. And we know the values of b and d. So we are putting the values of b and d in this equation. That means 2a, b is minus 2, 2a minus 2 plus 4c plus 4 times minus 1, which is 2a plus 4c yeah, 2a plus 4c minus 2 minus 4 is minus 6. Now let me write that line. 2a minus 2 plus 4c minus 4, which means 2a plus 4c minus 6. And that means if I bring minus 6 to the left hand side, I'm going to have 6 equals 2a plus 4c, which is the same as 2a plus 4c equals 6. That is equation 2. Now I can solve 1 and 2 simultaneously for the values of a and c. Solving 1 and 2 equations. Solving equations 1 and 2 simultaneously. And why are we doing that? That's to obtain the values of a and c simultaneously. What's equation 1? 4a plus 2c equals 6. 4a plus 2c equals 6. And equation 2, 2a plus 4c equals 6. 4a plus 2c equals minus 6. Equation 1 is 4a plus 2c equals minus 6. That's it. You've got to be very, very careful not to make mistakes, because it's very, it's very annoying, or let me say painful, when you get to the end and see that you made a very, very avoidable mistake. So what do? I want to eliminate c first. So I'm multiplying equation 1 by 2 to make the coefficient of c in the two equations the same. And I'm multiplying equation 2 by 1. So equation 1 becomes 8a plus 4c equals minus 12. And equation 2 remains what it is, 2a plus 4c equals 6. Now I can subtract equation 2 from 1. 8a minus 2a is 6a. 4c minus 4c is 0. So 6a equals minus 12 minus 6 is minus 18. And that means a equals minus 3. A equals minus 3. Beautiful. Now putting a in equation 1 you can put it in either 1 or 2. Putting it in equation 1, 4, wherever you see a, you write minus 3. 4 times minus 3 plus 2c equals minus 6. And that means minus 12 plus 2c equals minus 6. Which means 2c equals minus 6 plus 12. And that means 2c equals 6. Which means c is equal to 3. C equals 3. Yeah? So we have A, we have C, we have B and D. We have B, we have D. Then we are done. Therefore, x minus 2 divided by x minus 2 over x squared times x minus 1 squared is equal to A, which is, what is A? Minus 3 over x. Minus 3 over x plus B. What is B? Plus B, which is minus 2. So plus minus 2 is the same as minus 2 over x squared plus C, which is 3 over x minus 1 plus D, which is, what is D? I think that's minus 1 plus minus 1, that's minus 1 over x minus 1 squared. X minus 1 squared. So that's it. X minus 1 squared. And that's it simply. You can rearrange if you like and have the negative fractions in the middle. So that's it. That's minus 3 over x minus 2 over x squared plus 3 over x minus 1 minus 1 over x minus 1 squared. And that's it simply. So this is how simple it is, how simple and easy it is to resolve a fraction which has repeated factors as a denominator. It's just a piece of cake. You only have to be careful not to make mistakes when you expand, when you do your expansion, and when you solve equations that you obtain as a result of that simultaneously. Oh yeah, when you do your expansion and compare coefficients, and then as you solve the equations that you obtain by comparing coefficients, if you can be careful enough to do all of that correctly, then you will get the answer very, very easily. That's it on equations with repeated denominators, and I hope you enjoyed the video. Please subscribe to these channels for notifications. Subscribe to this channel to watch many more videos that will be uploaded, and click on the bell so as to be notified as soon as another video is uploaded. Thank you very much, and God bless.